Welcome to the Vision Break. In this video, I'll show you how to train DETR object detection models. You can see a few examples here, dog and cats. And I have one more example. You see there's two bounding boxes, label information and confidence value. And in this video, I will directly show you how to train DETR object detection model on custom datasets. But if you want to learn more about object detection in general, you can read this article. For example, single stage detectors, two stage detectors, and finally transformer based detectors like DETR detection transformer. I will share a link in comment section and you can find all of the code from this link. You can copy and use it. So now I will directly start. And first step is you need to have GPU supported PyTorch environment. If you don't have one, you can follow this article. I explained everything step by step. It's not that complex. So it might take some time. This, for example, you see the PyTorch here. This is like 3 gigabytes. So depending on your connection, it will take some time. And if you don't want to spend time on it, you can directly go with Kaggle. Like it offers 30-hour weekly GPU usage limit, and it's more than enough for most of the case. And it's completely free. You can upload your dataset, create a notebook, and activate GPU. Then you can train your models on GPUs. Yeah, you can use Google Colab as well. It's up to you. But after this step, I assume that you have GPU supported PyTorch environment in some place. And after that, you need to clone this DETR repository. Let me show you that. You see there's some documentation here. Yeah, there's pre-trained models. And I already cloned it to here. And after that, there's a few more things. Yeah, like you can copy this two line. And let me show you. I get these lines from here, I think. Yes, here you see PyCoco tools. You need to install these. And if you got any error related to NumPy, you can try to downgrade NumPy. In my case, there was some error related to NumPy, and I downgraded to 1.23, and error was solved. Yeah, environment is finished. Now we will create a dataset. Now we are not gonna create because I used this dataset. I chose it randomly from RoboFlow. It's about dog and cat detection. There's two classes, dog and cat. Let me show you a few examples. Yeah, dog, cat, you see. Yeah, there's only one critical point, and it is that your dataset has to be in Coco format. If you are using websites like RoboFlow for dataset, there has to be some options about this. Let me show you. Yes, you see there's different formats. You need to choose this Coco JSON format. If you have different format like YOLO, you need to convert it to Coco format. It's not that hard. You can find some tools, or you can directly export your dataset in Coco format. So let me close this. So let me show you my dataset here. You see here, there's three folders: training image, validation image, and annotations here. You see, for example, bounding box information, category ID. This is dog or cat. I don't know. And there's one more critical point. You see, by default, your folder names must be like this. Exactly, train 2017, val 2017. And your annotations file must be in this format, like this name, instances train 2017.json. But of course, you don't have to stick with this. You can go to DETR datasets and coco.py, and you can change this. You see here. Yeah, you can name it whatever you want. But in my case, folder names are same, so I'm gonna stick with this. But you can change this JSON file name as well. It's up to you. Yeah, as I said before, this is under coco.py file. Okay, we can continue. So yes, so other step is we need to download some pre-trained models. Like as I showed you before, you can directly download these from DETR repository. You see there's pre-trained models, or if you want to use same with this one, it has to be DETR, yes, ResNet 50. You see here, I'll use this ResNet 50 model. You can directly click this and it will start to download. So I already did that and copied to here. I created a new folder named pre-trained weights. I copied my model to here. I will use this pre-trained model. And yeah, this is This line is for training. Let me copy this. Oops. And let me open a new terminal. First, I need to activate my environment. DETR I name it. And I want to show you that this environment is GPU supported. First, I need to import PyTorch. Then I will print yes, torch that's CUDA that is available. Yes. Oops. Not 9. Yeah, you see it says true, so my environment is GPU supported. Okay. So training. Okay, for training we have this line. But of course you need to change this paths. I need to change it as well because this is not same with this one. You see here datasets, copy paths. And okay, I need to change this to this as well. Okay. Yeah, you see same with this one. And you see you can change this batch size to 4, 8, 16, whatever you want. But of course if you have powerful GPUs and it has to be divisible with like 2, like not 2, sorry. Yeah, you can set it to 2, 4, 8, 16, 32 if you have powerful GPUs. And you can change this epoch number. And there's one more thing, this path to the pre-trained model. And we need to go this. Oops, what happened? This is weird. Yeah, okay, we are good. Yeah, you need to go this better folder. You see, inside of this we will, because we will use this main.py. Let me copy this. Hopefully training will start. And I want to show you my GPU usage from top right. I hope you can see, for example, I expect this number to be increased. Training is starting. And you see, for example, yes, it loads annotations. Here you can see the learning rate. And yes, you see GPU usage is increasing. Training is started. This is first epoch. So you can see the values, lost values. And this will take some time. So after training is finished, I will continue. Okay, so training is finished. You see here, training time, 26 minutes. You can see some values here, like average precision values, you see, for different intersection of units values. And now we can start to test this model. But before that, we need to import these libraries. And I will import one more thing, but you don't have to import it for now. If you got any kernel error, you can import this. I think I can close this like this. Okay, let me continue. Okay, these are our classes. You see this first one is for background, cat and dog. And these colors are for visualization. Yeah, you can change these values, it doesn't matter. Okay. First, this one, I want to copy this one. So we basically here are resizing our image, and there's one important thing, this DETR models, detection transformer models, it can work with dynamic image resolutions. Like even if you write here 800, this will work. And here we are converting image to tensor, and here you can see the normalization. These values are ImageNet normalization values. Okay, let me copy these two. Yeah, these functions are not that important. You can even change this. For example, this is for changing the format. You can see this is center format, and we are converting it to corner format, like rectangle coordinates directly. And here, this is function for to rescale bounding boxes, because bounding box coordinates are normalized. They are between 0 and 1. So in this function, we convert it to real pixel values. And this function is for visualization. I'm not going to explain this one. So we basically draw rectangle around image. So continue. Okay. This one is, this one contains information about model. You see here backbone, number of classes. If you have different like if you have different data set, you need to change this value. For example, if you have 5 class, you have to change it to 5. And you can see some parameters about model, hidden dimensions. So these values are all depend the pre-trained model. Yeah, you see the arguments here, this one. And we are using build function. Let me show you that here. We are building the model and we will use this model. You see here, this is the trained model. Let me show you that as well. Where is that? No, outputs. Yes, here. Yeah, you can. There's logs as well, but we will use this checkpoint model. And here we are. You see the model is in evaluation mode because we are not gonna change any parameter. We will only use this model. So this is in evaluation mode. Yeah, this is our model. You can see the architecture. You can see the layers. Okay. And now we can make prediction. Let me close this, but we need to change this path. For example, this one. Let me try this. Okay, so we basically are reading image, adding patch dimension, and we apply transforms. We are moving our model to GPU for faster inference. Actually, we are moving our image here, and we are running model. You can see here we have probabilities. I will show this. Okay, you see the output, and I will show you this. For example, this one. You see these are like raw values. So we are applying softmax to obtain probability values. Let me show you this. So, and you see here, if the probability value is more than 0.5, we are keeping this. And you can change this value. Let me show you like this. Yes, you see. For example, this one is solo. And for example, let's say you can say like 0.8 as well, but since the confidence values are too high in this case, you see there will be again 2 detections. And we are plotting the results with this function. We just write it to here. Let me show you. It's this one. So as I said before, let me show you. We can change this value to even 3000 and it will still work. But it will take so much time. Let me show you. So like that was 0.8 seconds, and now you see, like it's more than 5, 6, 7. Okay, it takes really long time. Maybe 3000 was too high and CUDA out of memory. Yes, this is expected because this is too high. Let me change this to, for example, this one. I don't have to run this again. Maybe this one, yes. Okay, you see, 1 second. Okay, it makes sense. So I have one more image for testing. This one, for example. Yes, let me run this. Yeah, you see the cats. And let me, for example, reduce this value to 0.2. I think there will be, yes, too many bounding boxes. So like this. And I think, yes, if there's something else. Yeah, by the way, you don't have to train model, like you can use pre-trained models like this. Let me show you quickly. So now I will only use the pre-trained model, and you see these are Coco classes. Since we are using pre-trained model, we have to stick with these tables. Okay, again same transforms and plot result function. Here I'm using ResNet 50 as pre-trained model, and I'm not gonna train any model. I will directly use this one. Okay, cat image, again same things, and output. Oh, big. Yeah, you see, it says cat. So yes, I think that's it for this video. Thanks for watching. See you soon.